March is often a transition month when severe weather ramps up and tornado frequency begins to rise across the United States. But will March 2025 be an active month for tornadoes? In this video, we'll analyze climate patterns, historical trends, and key atmospheric indicators to forecast the tornado risk for March. Let's break it all down. Looking at historical tornado trends, March is a pivotal month for severe weather. The map on the left shows where tornadoes touchdown have occurred between 1950 and 2014, with a high concentration across the southern United States. The map on the right highlights the average number of March tornadoes per state from 1999 to 2023, showing that Texas, Alabama, and Mississippi lead the country in March tornado activity. The Southeast and lower Midwest see a sharp increase in tornado frequency during this month as warm Gulf air clashes with lingering winter cold fronts, creating the perfect environment for severe storms to develop. Climate patterns like ENSO or El Niño Southern Oscillation plays a major role in tornado activity by influencing the jet stream, moisture availability, and storm frequency. This year, we are trending toward a weak La Niña during March, meaning sea surface temperatures in the equatorial Pacific are slightly cooler than average. The right map shows sea surface temperature anomalies for March 2025, with warmer than normal waters in the Gulf of Mexico, the Western Pacific, and parts of the Atlantic. Warmer Gulf waters can enhance moisture return, fueling thunderstorms, while La Niña conditions can strengthen the jet stream, increasing wind shear, an important ingredient for tornadoes. These SST trends suggest an active pattern for severe weather, especially in the southeast and lower Midwest, where warm Gulf moisture will likely interact with stronger jet dynamics. Beyond ENSO, other large-scale climate oscillations also shape tornado risk. The Arctic Oscillation, AO, is currently trending positive into March, meaning the polar vortex remains strong, keeping cold air locked in the Arctic. This reduces the likelihood of deep cold air intrusions that can suppress tornado activity. The North Atlantic Oscillation, NAO, is slightly positive, favoring a more zonal jet stream across the United States, which can limit deep troughing but still allow for storm systems to track eastward. The Pacific North American pattern, PNA, is trending negative, meaning more troughing over the western United States, which can enhance storm activity in the central and eastern United States by increasing instability and wind shear. The Madden-Julian Oscillation, MJO, is a key factor in severe weather. Phases 6 through 8 tend to bring enhanced Gulf moisture return, while phases 1 through 3 suppress storm development. Watching where the MJO moves in early March will help determine when and where severe weather is most likely to develop. To summarize these oscillations, a positive NAO suggests a more zonal flow, which can reduce cold air intrusions and make the environment less favorable for tornadoes. A positive AO keeps the polar vortex strong, limiting disruptive Arctic outbreaks that could suppress storm activity. A negative PNA shifting storm activity further west. With these patterns in mind, let's look at how they will influence March temperature and precipitation trends. Now let's examine temperature and precipitation forecasts for March 2025. Above average temperatures are expected across the southern plains, the southeast, and parts of the mid-south. This warming increases instability, helping storms become more organized. Meanwhile, wetter than normal conditions are forecast across the southeast and Midwest/Ohio Valley, favoring increased severe weather activity. Drier conditions in the southwest and parts of the plains may temporarily limit tornado activity unless moisture return increases later in the month. The 8 to 14 day trend suggests a slightly cooler to normal stormy pattern entering early March rather than purely warm conditions. These trends support a favorable setup for severe weather in the southeast and lower Midwest, particularly as moisture increases later in the month. The position of the jet stream is crucial in determining tornado risk. By early March, ensemble models suggest a strong jet stream dipping into the southeast, increasing tornado potential. Stronger wind shear, which helps organize storms and increase tornado risk. A persistent jet stream positioned over the southern plains and southeast, suggesting a heightened tornado threat. If the jet stream amplifies, storm systems could become more intense, leading to potential severe weather outbreaks. If this pattern holds, the risk of tornadoes will increase, especially in the southeast and lower Midwest. For tornadoes to develop, four main ingredients are needed: CAPE, convective available potential energy, provides the fuel for thunderstorms. Wind shear, needed for supercells and tornadoes, increasing storm organization and rotation. Forcing mechanisms, jet streaks, surface lows, and frontal boundaries help trigger storms. Moisture return, Gulf moisture is critical for instability. Right now, models suggest early March most favorable tornado areas will be in the southern Louisiana and Mississippi region. But if moisture increases, risk zones could expand farther north. Looking at historical tornado tracks from 1950 to 2014, we see that the southeast, southern plains, Midwest, and Mid-South have the highest tornado frequency. EF3 to EF5 tornadoes have historically impacted the Southeast, Mississippi Valley, Ohio Valley, and Southern Plains. If past trends hold, these areas may see increased tornado risk in March 2025. When forecasting tornado risk for March 2025, looking at past years with similar atmospheric setups can provide valuable insight. One of the strongest analog years for this forecast is March 2008, a month that saw widespread tornado activity across the Southeast, Midwest, and Gulf Coast. So why does March 2008 serve as a strong comparison for 2025? First, March 2008 featured a weak La Niña transitioning towards ENSO neutral, closely mirroring what's expected this year. This transition plays a critical role in shaping jet stream patterns and moisture return. Second, MJO phases 6 through 8 were dominant, which historically supports increased Gulf moisture. Additionally, the positioning of the jet stream in 2008 aligns well with 2025 projections, meaning similar storm tracks and areas of instability are likely. Finally, CAPE and wind shear values in 2008 were highly favorable for tornado outbreaks, particularly in the Southeast and lower Midwest regions that are once again highlighted in this year's outlook. Now let's summarize what happened in 2008 of March and why it matters for 2025. March 2008 saw widespread tornado activity with multiple severe outbreaks occurring throughout the Southeast, Midwest, and Gulf Coast. The most violent tornadoes, rated EF3 to EF5, were concentrated in Alabama, Georgia, and South Carolina. These long-track, high-impact tornadoes resulted from the favorable large-scale setup of that year. Given that ENSO and MJO phases in 2005 align with 2008, it suggests that similar risk zones should be expected, especially across the Southeast, Gulf Coast, and lower Midwest. By studying these historical trends, we can better anticipate the regions most at risk and prepare accordingly. Now let's break down the final tornado risk forecast for March 2025. This map highlights 3 distinct risk zones based on historical trends, current climate signals, and projected atmospheric conditions. High risk zone, in pink, includes Mississippi, Alabama, and Tennessee. This is the area with the greatest tornado potential, where the environment could support strong or long-track tornadoes similar to past outbreaks in these states. If jet stream positioning and stability and moisture return align, this could be the most active tornado zone of the month. Medium risk zone in red covers Arkansas, Louisiana, Georgia, Missouri, and Kentucky. Here, tornado risk remains elevated, though less consistent than the high risk zone. Strong tornadoes are still possible, especially during periods of an increased instability. Slight risk zone in yellow. This broader area covers much of the southern and central United States and includes portions of Texas, Oklahoma, the Midwest, and the Ohio Valley. Tornadoes in this zone will be more isolated depending on moisture return and local storm development. Why this risk map makes sense: historical tornado activity in March, combined with the expected jet stream pattern, moisture availability, and instability, all support this active tornado outlook. Past analogs like March 2008 further reinforce this risk area, showing that similar climate conditions have led to increased tornado outbreaks in the same regions. To summarize, climate patterns suggest an active March for tornadoes, especially in the southern and lower Midwest portions of the country. Let's recap our risk zones. High risk, Mississippi, Alabama, and Tennessee. Medium risk, Arkansas, Louisiana, Georgia, Missouri, and Kentucky. Slight risk, a broader portion of the southern and central United States. Stay weather aware, monitor forecasts, and be prepared. If you found this forecast helpful, subscribe and stay ahead of severe weather this March.